So at this point, we have started talking about three-dimensional geometry, solid geometry. We started talking about solid geometry by just being able to recognize the shapes and some of the vocabulary around some of the shapes. Yesterday, we started talking about surface area and combined that kind of with the information we've done with area before. Today, we're taking it to a new dimension, quite literally. The third dimension is a measure of volume. So when we look at the three dimensions, we start with one dimension. That's just length, the distance, whatever you want to call it. And so we can measure that as 1 centimeter, 1 foot, whatever. And it's just a single dimension. We can see it, it's just length. When we add a second dimension, we add width. That makes it a flat shape on a page. And so we measure in 2 dimensions with area. Because it's centimeters times centimeters, that gives us centimeters square, or square units, whatever the units may be. When we move into 3 dimensions, we add the third dimension, length, width. We usually add height to it. So that means we now have 3 dimensions going on here. And that gives us these cubes. So when we're measuring in 3 dimensions, we're measuring in terms of how many of these little cubes, cubic centimeters, cubic feet, whatever they are, how many cubes can we toss into our object? How many of these little cubic centimeters can I use to fill up the object that we have? So that's the big difference between surface area and volume. Surface area talks about the flat space, how many of these squares can I fit on the outside, whereas volume is talking about how many of these cubes can I put inside. So we have to recognize the difference between surface area and volume because both of them may give us a problem that looks like, over here on the right, a 3-dimensional object. I could give you the same 3-dimensional object, and I could say, find the surface area and find the volume. You have to recognize those as 2 different things. The most common mistake I see on the CST, benchmark test, unit test, whatever it is, with these problems is I see a problem like this, and immediately, without reading the problem, somebody starts solving for surface area. And then when you go back and read the problem, it says, what's the volume? Okay, they're not the same. We know that. All right, so what exactly is volume? Somebody give me a good definition of volume because this is a vocabulary term we need for this test. Jordan? The space inside of a 3-dimensional figure, I'm going to take his word space and I'm going to expand on it, is the space. And when we're talking about it quantitatively, we're going to talk about the number of cubes. To fill the inside of a shape. Nope, not to find, to fill, Mr. Boots. Summer shimmer. All right, hold on. There we go. 3D solid. All right. So what are the units of volume? How do we measure the units of volume? Joel? What are the units of volume? Cubic, whatever, yeah. So, and if we're just talking about general units, it's cubic units. Or we might write it as units to the third. All right. Also, this should be review as well. What is the formula of the volume of a rectangular prism? Rita. E equals length, butterfingers, times width, times height. Now, this is the volume of a rectangular prism, so I'm actually going to put a little RP down here. Remind us, this talks about rectangular prism, because you can find volumes of different shapes. Does anybody know a general equation, a more general equation for the volume of any prism? Joelle?
V equals height times
Jordan, what do you think?
V equals multiplication of each different case.
Okay. I kind of see where you're coming from there. Say that one more time. Width times height. So we're still missing. So where this length and width come from, and this is something that I didn't think was probably a review for you, but I do want to talk about, because you should be able to find the volume of any prism as long as you can find the area of its base. So the way we get our rectangular prism is we take our length and our width. Maybe we call this the base of our rectangular prism, and then we multiply it by how deep it goes. So really, we're finding the area of the base, and we're multiplying it times the height. The reason I bring that to your attention is because I want you to push your understanding of the volume of prisms. You're going to find on your can-do today, you're going to get a prism that is a hexagonal prism. And you should be able to find the volume of that if you're thinking about this concept. Okay, you can find the area of the base. I think they give you the area of the base in the can-do problem. And they give you the length. And so all you need to do is multiply the area times how deep it goes. So, and that's the same idea. If you can't remember the equation for the volume of a rectangular prism, remember, the area of that base, that's just length times width. And then you're multiplying by how deep it goes. Okay? So we're looking at the problems today. Interesting situation. Mr. Curry is trapped in a room with no ventilation. He knows that Mr. Boots will be there in 3 hours to save the day. In order for him to survive, there must be at least 500 cubic feet. Switch your units there. That's wrong. Some unit of volume. It should be. There must be at least 500 cubic feet of air in the room. The room he is trapped in is pictured below. Will Mr. Boots make it in time, or will Mr. Curry die a painful, suffocating death? Dun, dun, dun. All right, so we need to find out how much volume of air is in the room itself. So let's talk about this room. How do I find the volume of this room? Three hands, really? Really? That's all I got? 3 hands? 4 hands, really? Really, that's all I got? 5 hands, really? Really, that's all I got? All right, you're gonna force me to cold call somebody. Layla! How do I find the volume of this particular room? So multiply the length and width of the height. So we recognize that this is a rectangular prism. So the volume of a rectangular prism is length times width times height. So we need to figure out what the length, width, and height are. So as I'm going through and labeling this, you should be labeling it as well. So I think about the length as this 5. So I'm going to label 5 feet is equal to the length. I think about this 8 being the width. And I think about this 6 feet as being the height. Now, let me ask you a question. Let's say you think of those things as just a little bit different. Maybe you think of 8 as the length, and you think of 5 as the width. Is that okay? Is that going to be okay? Why is that going to be okay? Patricia? Yeah, so it's multiplication, it's commutative. It doesn't really matter what order these terms get put in, as long as we make sure that we are actually indeed talking about the length, width, and height. So I'm going to quickly multiply. 5 times 8 is 40. Times 6, that's another one I can quickly do. That's 240. The volume is equal to 240
Feet squared.
feet
Cube.
cube. Remember, we're talking about volume here. Three dimensions, which means we're talking about cubes. How many cubes can I toss into that room? 240 foot-sized cubes of air we can toss into that room. Now, what's the unfortunate news for Mr. Curry?
He will die. He will die.
He's going to die a painful, suffocating death. Wah. Hey, but good news. It says Mr. Curry finds a secret door in one of the walls. The door opens up to a long hallway and another room. In total, the room he is in, the hallway, and the second room have the dimensions below. With the newfound rooms and their volumes of air, will Mr. Boots make it in time? Now, looking at this shape of this now area, or this volume that Mr. Curry is in now, is this a rectangular prism? Can I use length times width times height and go, well, all right, this looks like a width, that's 8. Let's call this 8, and let's call this 6, and say 8 times 8 times 6, that's the volume. No, we most definitely cannot. However, there is a way we can think about this where we can use the knowledge that we already have to sort this out. Intana, what master plan do you have to sort out the volume of this particular room setup? Okay, so he wants to find the area of the base times the height. However, there's not a consistent base that goes the entire length of any of this. So we can't use just one area of the base times height. Kind of gave a hint there. Edwin, what's your master plan? All right, so he's saying, all right, I see this as one rectangular prism. I see the hallway as a second rectangular prism. And I see the other smaller room as a third rectangular prism. Therefore, if I find the volume of each of them, I can add it together to find the total volume. This sounds very much like when we had complex shapes and complex areas, how we did that. So this is the same idea. We have a complex volume. We're going to chop it up into pieces, find the volume of the pieces, add it all together. Let's start with volume number 1, room number 1. So if I want to find the volume of room number 1, what is the shape of room number 1? Michaela? Rectangular prism, so our equation is length times width times height. So let's go ahead and label those things on our plot. I think about 6 as my height. I think about 8 as my length. And 5 as my width. So I'm going to plug that in. 8 times 5 times 6. 40 times 6 equals 240. Good news, this should be the same as the answer that we just got because this is the same original room that he was in before. So the volume in the first room he's in is still 240 cubic feet.
How? Oh, I put them.
All right, so let's move on to the hallway. What shape is the hallway?
Rectangle.
Rectangular prism, okay. And so that means we again are going to be using length times width times height. And we need to label our pieces here. So I think about this being my length, so I'm going to label 8 as my length. I think about this as my width, so that's going to be equal to 2. And I think about this as my height. That's also going to be equal to 2. So I plug it in, length of 8, width of 2, height of 2.
32.
16 times 2. The 2 is equal to 32 cubic feet. Sad news for Mr. Curry, that's really not a big gain for him, but he's got this whole other room. Maybe we'll sort it out with this other room. Volume of room number 3. Room number 3 is indeed also a rectangular prism, so our equation is still length times width times height. And I think of my length as this way, so that's going to be 3. Think about my width as 6. And I think about my height as 4. 3 times width is 6 times height is 4. 18 times 4. Volume 3 is equal to 36 is 72 feet.
Ew.
Oh, hold on. Try again.
You have a tissue?
72 feet cubed. Now, I hear some of you already exclaiming that Mr. Curry is going to perish, but how do you know? What do we need to do to make sure that we're right here? Desiree? Add it all up. We need to find the total volume, so that's 240 plus 32 plus 72. So our total volume is 344 feet cubed. So sadly, Mr. Curry's not going to make it. Now, it makes me feel bad because maybe